Page 11 of differentiation rules. How do you find the second derivative of f dash? You take the derivative, I'm sorry, not f dash, f of x. You take the derivative of f, just like we've always done, and then you take the derivative of the derivative function. This is not proper notation, but I'm just going to say you take the derivative of the derivative function. Okay? So let's write down some notation. So there's three ways that they might ask you for the second derivative. One is they might say f double dash of x. That's why I'm saying this is not proper notation. It looks like this. Double dash is the second derivative. Another way they might say it is they might say y double dash. And the other thing they might say is instead of dy dx, they might write d squared y over dx squared. Okay, so it's kind of tricky because the 2 goes here and then the 2 goes here. It's not the same. The 2 goes after the d here and then the 2 goes after the x there. Okay. Two different notations to represent the nth derivative. So if you can imagine, you can have two derivatives in a row on a given function. You could just keep doing that forever, right? So how do they show that? They show that by saying f to the n of x, or instead of putting a 2 and a 2 here, they're going to put an n. dn y dx to the n. So that would be the nth derivative notation. Okay, so here they say find f double dash, which means find the second derivative. Finding the second derivative means we're going to take the first derivative, and then after we get the first derivative, maybe we'll simplify it a little bit to make it easier to take the second derivative, and then take another derivative. And so if you know how to take one derivative, you know how to take two derivatives. So f dash is equal to 3. We just leave the coefficient there. We bring down the 2. We lower the exponent of x by 1. The derivative of 6x, we just take off the x, and the derivative of 2 is just 0. Let's simplify. 6x minus 6. That is the first derivative. What is the second derivative? The second derivative would be 6, because the second number is just negative 6, so the derivative of that is 0. So the first derivative is 6x minus 6. The second derivative is 6. Let's take the first derivative of this function. It's 2. Bring down the 3. Reduce it by 1. Leave the negative 3 there. Bring down the 2. Reduce it by 1. Derivative of negative 1x is negative 1. The derivative of 5 is 0. Let's simplify. It's good to simplify because then it's easier to take the second derivative. Second derivative, bring down, write down the 6, just leave it there, bring down the 2, reduce it by 1. Derivative of negative 6x, of course, is just negative 6. Let's simplify. Okay, so the second derivative is that. The first derivative is that. Oops, made a mistake. Derivative of negative 6 is just 0. Right, okay. F of x equals this. First derivative, let's use the chain rule. Function inside of a function. The outside function is cubed, so we're going to bring the 3 down. We leave the inside the same, and then we lower the exponent by 1. Then we take the derivative of the inside. It would just be negative 2. Let's simplify so that it's easier to do the second derivative. There we go. Now let's do the second derivative. The second derivative, we just leave the negative 6 there because it's a coefficient. We bring the 2 down. We leave the inside the same. We lower the exponent by 1. Then we do the chain rule of the inside, negative 2. Let's simplify this. Negative 2 times negative 12 is positive 24. 1 minus 2x, and to the first power is, we don't need to put a power there. If we want to, we could distribute this. It's not so critical to simplify anymore because we're not going to find the third derivative. But if we were going to find the third derivative, it would be nice to write 24 minus 48x instead. Find the second derivative given that this is our function. The first derivative is 1 minus 3x squared, right? Don't even need to simplify. Second derivative is 0, negative 3, bring down the 2, lower the exponent by 1, simplify, negative 6x. Okay, and for the second function, I'm going to rewrite this term as 3 to the x to the negative 1/2 because it's a little bit easier to see that we're going to use power rule. The derivative of 2 is 0. The derivative of negative 3x to the negative 1/2 is negative 3. We just leave the negative 3 there. We bring down the power and we reduce it by 1. Well, negative 1/2 minus 1 is negative 3/2. Let's simplify before we take another derivative. Negative 3 times negative 1/2 is positive 3/2. X to the negative 3/2. Okay, all we did was rewrite it so far. We haven't even taken a derivative yet. Now we can take the derivative. We leave 3/2, the coefficient the same. We bring down negative 3/2. We lower the exponent negative 3/2 by 1. It will be negative 5/2. That would be negative 9/4 x to the negative 5/2. Okay, so this is our second derivative, and the first derivative is this. Okay. Y equals x squared minus 3x quantity cubed. So the outside function is cubed. The inside function x squared minus 3x, we're going to use chain rule. The first derivative is bring down the 3, leave the inside the same. Lower the exponent by 1. Chain rule, 2x minus 3. And we're done. This is going to be a pain to take the second derivative of because we have a product, right? Not only that, but we have a coefficient. So we'll just leave the coefficient to the side. At the very end, we'll add it back in, okay? So we're just going to find the derivative of this part, all right? So we have a product. So this would be u, and this would be v. U dash would be 2, just 2. V dash would be power rule, 2x squared minus 3x. Inside stays the same. Then we do chain rule. The derivative of the inside is 2x minus 3. Ugly. Oh, it's the same thing again. How interesting. Okay, so now we're going to multiply this times this and this times this. We're just going to leave the 3 aside, remember? Okay, so first we'll do 2x minus 3. We'll do this times this, which is 2 times x squared minus 3x times 2x minus 3. How horrible. And then we're going to add that to 2 times x squared minus 3x squared. Okay, and so we could square these together. We could simplify a little bit because, you know, it's easy. Okay, and then finally, don't forget that we need to bring our 3 back in. One more easy thing we could do is we could factor out a common factor here. We could also factor out this 2. So on the outside, we'd have 3 times 2, and then we'd have our x squared minus 3x. What would we have left here? We would have 2x minus 3 squared. We already factored out the 2. We factored out the double line thing here. We factored out the 2, and here we would have left an x squared minus 3x, a single one, because there was a double, right? And we factored 1 out. And now we could FOIL that and combine like terms, right? And if you would like to do that for algebra practice, go ahead. If you would like to do that, compare it to the answer in the back of the book, go ahead. But I don't think it's worth the time. All right, let's see, number 3A. So they give us a function, and they want us to find the value of this function with 2 plugged in. Then they want to find the second derivative with the 2 plugged in, and then they want us to find the third derivative with the 2 plugged in. So in order to plug in the 2, we do need to find the first, second, the third derivative, right? So the function itself with 2 plugged in would be 2 cubed minus 2 times 2 plus 5, which is equal to 8 minus 4 plus 5, which is equal to 4 plus 5, which is equal to 9. Okay, what about the second derivative? The second derivative, we haven't even found the first derivative. The first derivative would be 3x squared minus 2. Ooh, the good thing about polynomials is when you do first and second derivative, they just get simpler and simpler. The second derivative of 3x squared minus 2 would be 6x to the first minus 0. So it's just 6x. So f double dash of x is 6x. F double dash with 2 plugged in is 6 times 2, which is 12. The third derivative with 2 plugged in. So let's find the third derivative. Remember, the second derivative is, I'm just copying it down here, is 6x. So the third derivative would be the derivative of 6x, which is just 6. And if we plug in 2, there's no x to plug into. Actually, the third derivative is always 6, no matter what the x value is. Kind of a trick question. Okay, so the third derivative with 2 plugged in is 6. The third derivative with 8 plugged in is 6. No matter what you plug in, it's still going to be 6. All right. It's kind of like the derivative of a line, right? The derivative of a line is always the slope. And it's the same slope because this line is straight. Okay, now we're going to have kind of an algebra problem where they give us a function with 2 letters in it, which are supposed to be unknown numbers, but they're not the variable. What's the variable? X as usual. How do we know it's x? Because when they ask us to take the derivative, they give us x in the denominator, so that says treat everything else like a number. So what we want to do is, this is a show that problem. So what we're going to do is we're just going to say, okay, I'm going to look at the left side, and I'm going to do what it says on the left side, and let's see if I get the right side. Okay, now you don't look at the right side. You just look at the left side. Okay, so what is the derivative of this function? Well, if you treat capital A and small k as numbers instead of variables, it's just like, it's capital A is a coefficient. You just leave it there. The derivative of e to the kx is just e to the kx with chain rule. We're going to do the derivative of the inside function because the outside function is e to the something. The inside function is kx. When we multiply by the derivative of the inside function, remember, a number times x, the derivative is just the number. So there's my derivative. It's a k e to the kx. And then we say, oh, what am I supposed to make it equal to? Ky. Oh, yeah, actually I see that this and this together is y. So I could say this is equal to ky, right? And I'm done. Okay, if it's not obvious to you, you can rearrange the order of a and e to the kx and group them, and then we say, oh yeah, now it is ky. Okay, so we've done part A. Part C, we're going to take the third derivative of this function, and then we're going to check to see if it's equal to k cubed times y. So we're not going to look at this first. Let's take 3 derivatives. Okay, the first derivative is this. Okay, the second derivative would be, okay, so like ak is a coefficient. We're just going to leave it there. Then we're going to take the derivative of e to the kx. The outside function is e, so we just rewrite it with the inside function the same. Then we do chain rule. We multiply it by k. So our simplified version is ak squared e to the kx. That's the second derivative. Okay, let's do the third derivative. The third derivative, ak squared, is a coefficient. We leave it there. e to the kx. Let's take the derivative of that. The outside function is e to the something. Inside function is kx. We just take the derivative of the outside function. We just rewrite the whole thing with the inside the same. Then we do the chain rule on the kx. We multiply it times k, because the derivative of a number times something, x, is the number. So kx, the derivative is k. AK squared e to the kx. Okay, and then, k cubed, right? Because now we group it with one more k. All right, and then we say, okay, let's rearrange it. What if we group a and e to the kx together? And that's equal to y, right? So this is equal to k cubed y. So the third derivative of the function is equal to k cubed y, and we just showed that too. Now, why do they have us do this? Because we already know that taking the derivative of the exponential function, you just get another exponential function. Now, if the exponential function is not just e to the x, if it's like e to the 3x or something like that, you can see that whenever you take the derivative, the 3 just keeps popping out because of the chain rule. You just get 3's popping out all the time. So if you do 3 derivatives, you just get 3 3's popping out, okay? And the fact that this derivative of this particular function is always the same function, just multiplied by a coefficient or a vertical stretch, is why the exponential function occurs a lot in nature. Because in nature, a lot of times things behave according to equations where the rate of change of something is dependent on the quantity of something that you have. So think about like bacteria. If you have a lot of bacteria, the amount of the increase in the amount of bacteria is a lot also. Okay, and if you don't have very much bacteria, the increase in the amount of bacteria is very small, because the increase in the amount of bacteria is proportional to the amount of bacteria that you have, which, totally makes sense. Okay, but it turns out that when you define that relationship, you define it with an equation like the increase in the bacteria is equal to the amount of the bacteria that you have, maybe times a constant. And you can see that the y function which satisfies this equation is the exponential function. So that's why bacteria grows as an exponential function. It decreases according to the exponential function. Many things behave according to exponential functions in nature because, the increase in something or the decrease in something depends on, the amount of stuff that you have, is like a really common thing in the world. Okay, it's one of the most simple rules that happens to occur, which has roots in things that make sense, right? It's like if you have more people are giving birth, so the increase in the number of people is bigger. If you have too many people, the amount of people maybe is related to the amount of people that die because there's not enough food to feed those people. So organisms grow and die according to the exponential function because the rate of increase or decrease of the organism is usually related to the amount of organism that you already have. Okay? Yeah. All right. So last question here, number 5. Find x when the second derivative is equal to 0 for this function here. Okay, so we're going to have to find the second derivative, and then we're going to set it equal to 0 for some reason. Okay, so let's find the first derivative, and then we can find the second derivative after that. So the first derivative, this is a quotient. So the top is u, the bottom is v. The derivative of u would be 1. The derivative of v would be 2x, and that's it, right? So now what we need to do is we need to fill in the quotient rule. So v squared is the bottom, so it'd be x squared plus 2 squared. The top would be x squared plus 2 times u dash, which is 1, subtract u, which is x, times v dash, which is 2x. And let's simplify this. Normally, we don't need to simplify, but when we take the second derivative, of course we want to simplify. Otherwise, our second derivative is going to just be hell. minus 2x squared. Okay, and then on the bottom we have that same expression. Let's combine these, right? Because the minus 2x squared plus 1x squared would be minus x squared. Okay. Okay, so here is our new second derivative, or first derivative function, sorry, first derivative function. Now we need to find the second derivative of this function. Okay, so again, we have a quotient, and the u dash would be negative 2x. The v dash would be 2 times x squared plus 2 to the first times chain rule, which would be 2x. So I could simplify that to be 4x x squared plus 2. Okay, now I'm going to fill it into the quotient rule for the second derivative. So on the bottom, I'm going to have, whoa, what happened? Okay, on the bottom, I'm going to put v dash. So it would be x squared plus 2. Instead of squared, it would be to the fourth because I'm doing squared of v. On the top, I'm going to put just plain v times u dash, which is negative 2x. And then I'm going to put minus, and then I'm going to put u, which is 2 minus x squared, and then I'm going to put v dash, which is that mess. Okay, that's horrible. Let's see. I don't know if it's even worth factoring something out, but I can. I can factor this out, not the squared. But, and then I would leave minus 2x and x squared plus 2 to the first, and then minus 2 minus x squared times 4x. Okay. Yuck. And on the bottom, I would have x squared plus 2 to the fourth, and I could cancel, like, see, I could cancel like this out with like one of these, right? That would make it a little nicer. Okay, so now I have the second derivative reasonably simplified. Now they said to set it equal to 0. Yeesh. Okay. Now, if I want to know what the solution to this is, then I would see when the numerator is equal to 0. Okay? So I really would need to simplify this now, right? Okay, but I only need to simplify the numerator because I don't care about the denominator, right? The numerator is 0, the whole thing is 0. So let's do a shower for this. Negative 2x cubed minus 4x minus 8x minus 4x cubed with something on the bottom. Okay, and then I will shower this, and this would be negative 12x. This would be 4x cubed minus 2x cubed, so it would be 2x cubed minus 12x over something cubed equals 0. So now I know that 2x cubed minus 12x is equal to 0. There's a couple solutions to this. One of the solutions would be x equals 0, right? The other solution would be this is equal to 0. 2x squared minus 12 is equal to 0. X squared is equal to 6, right? I add the 12 to both sides, I divide 2 both sides. X is equal to plus or minus the square root of 6. So either 0 or x is equal to plus or minus the square root of 6. Those are the two solutions to this ungodly equation.